Question 4, it's a big number, 252, and to be honest, I'm looking at those, it's not obvious to me which one has been, we simplified that. So I'm actually going to do this question backwards and think about if this was a surd, 144 times root 121, that would be a number that's way bigger than 252. So that one can't be it. This one here, that would be 9 times 14, root 9 by root 14. That's less than 140, so that one's not it either. 36 times 7, root 36 times root 7. As I'm doing this backwards, I'm not simplifying, I'm making the answers entire surds. 4 times 7 is 28, so we're certainly in the ballpark there. And this one, 7 times 7 would be 49 times root 6, root 49 times root 6. That 6 times 50 is 300, so it'd be very, very close to 300, so it can't be that one. So the answer's got to be B. And I'm trusting. I still haven't worked out what that is, but judging by the rest, it's got to be that one. Question number 5, we've got a pretty simple subtraction. Remember, we can treat surds like an algebra term. If this was 11x minus 6x, we'd know we'd have 5x's left. 11 lots of root 10 minus 6 lots of root 10 leaves us with 5 lots of root 10. Another multiplication like we had to do up there. 3 times 7 is 21 times root 5 times root 3 is 21 root 15, and we've got that good. Another subtraction, I've got 8 lots of root 7 and I'm taking away 3 lots of root 7, so there's only 5 lots of root 7 left. The conjugate is just something, one of those things you have to remember, that we're going to change the term in the middle. It's going to be the square root of 3 plus the number 4. That's the conjugate relationship, so we need to find that. The answers are a bit tricky. If you change both the signs, you'll get that one, but that's not what you do. If you turn them around, you'll get that. Yeah, that's not what you do. If you change the front sign, you'll get that. You just change the sign in the middle, so it's D. Just change the sign in the middle. The simplest form of this, so it looks like we're going to multiply that in and then do some simplifying. So 2 root 3 times 5, 2 root 3 by 5, where's my 3, there it is, and 2 root 3 times negative root 3, so it'll be a negative term, 2 root 3 by root 3, so I've got that negative there, so that's 10 root 3, and that is 2 lots of the square root of 9, and the square root of 9 is the number 3, which is the number 6, so it's 10 root 3 minus 6, and there's 10 root 3 minus 6. We're gonna rationalise. Alright, so rationalising. When I read that word, the conjugate idea went off in my head, but I don't have anything to make a conjugate with. It's not 6 plus root 6 plus 2 or root 6 minus something. It's just the square root of 6. So we're just going to multiply by the square root of 6. 2 root 5 on root 6 times that by root 6 and that by root 6 equals, so that'll be 2 lots of root 30 over the number 6, and I think we'll find that's not there. 2 root 30 on 6, we've got a bit of cancelling to do here. How many 2's are there? 1 root 30. How many 2's are there? 3. So we got 1 root 30 over 3, which is what this answer is here. So we just simplified that fraction there. So potentially you can get that wrong, just even if you can do the third part, because your fractions are a bit rusty. To rationalise the denominator, you would multiply by, okay, so here's our conjugates that we were doing before. We need the conjugate of the bottom term, so that's going to be 2 plus root 3, 2 plus 3 root 3, 3 times root 3. And so you would do that on the bottom, you would also do that on the top. So that's this one here. You're going to times by it on top and by it on the bottom. Excuse me. And that's the end of page 1.